Alright, so believe it or not, that's pretty much everything I need from, or I needed to go over for Chapter 1 before we can move on to Chapter 2. Now, there's a lot of other things in Chapter 1, like interfaces, abstract classes, generics, and wrapper classes, but I don't need to touch them. Or rather, they're boring subjects on by themselves, and it really is just never made sense to me to go over these things before you hit lists and array lists. So we're going to go over, we're going to start Chapter 2, and this will be the bulk of the next couple weeks. It'll be basically most of the first exam will be Chapter 2. Now, that might horrify you because you're like, oh God, does that mean, that we're having an exam, very soon? Kinda. You'll probably have your first timed lab over some of the content in this chapter in the third week's lab, and then you'll probably have your actual exam around the fifth or sixth week in the lab session. So it's never earlier than the fifth week, and I've never done it later than the sixth week. And and if we push it back to the sixth week, then I like to include some other material, like stacks and queues, in there, because once you understand linked lists and array lists, stacks and queues are easy. They take about a lecture apiece, lecture and a half if I want to really do them justice. All right, but we'll introduce the concepts of interfaces, generics, wrapper classes as we need them, as we go over them. So let's go over what Chapter 2 is, because I make it sound like it's a big deal, but it's all about lists. So what do we need to go over? We need to go over the list interface, writing an array-based implementation of a list, linked list data structures, singly linked lists, doubly linked, circular. So big O notation, algorithm efficiency. So let's just kind of, we'll go over what these mean in a bit, but basically, this is saying we're going to go over what is a list, how to build an array list, an array-based list, a linked list, which is, you might think it's built with links, but really it's it's basically doing a scavenger hunt through your computer is the way I like to use the metaphor. Big O notation, algorithm efficiency. This is a nice one, and it's basically as close to math as we're going to touch in this class, which is a mathematical notation to note how fast or slow your algorithms or the methods you write are. Implementing these, the list interface as a linked list. So basically, we are going to write an array list and a linked list on our own in these videos, and you'll be doing a circular linked list yourself as part of one of your homeworks, which is generally considered like one of the big humps of difficulty in this class. But if you can do that one, then you can basically be sure that you're going to be able to handle the rest of the workload for the class. So I like to give you an idea of how difficult the work is pretty early. All right, so the first thing we need, so I think I'll actually back up here, and actually this makes a good point as to what are we actually all going to cover in this class, because I really haven't talked about that too much, really. I'll probably talk about it more in our class, but why don't I go ahead and just list out. So we're going to be going over data structures, right? That's kind of the name of the course. So what are data structures? They're ways we can collect data and organize data and put them in a useful format to solve problems. That's probably a terrible definition, but it's a good working definition for us. So what are the common ways we manipulate? We do these. We manipulate and organize data. We can create lists, which we learned that means either an array list is one we're going to go over, and a linked list is the other one. And there's different flavors of linked list. Okay. What else have we got? We've got stacks. We've also got queues that we're going to tackle. So then we're going to tackle trees, and there's going to be a heck of a lot when we tackle trees. Okay. like we'll be going over binary search trees. But we're also going to go over, heaps and up-in trees to learn a bit of compression. Okay, and then we'll be learning about hash tables, which is my favorite chapter because I may have done research in that area. Specifically, we're going to be using, we're going to be learning how to use a hash table to build sets, like the mathematical sets, which is not nearly as hard as it sounds, and maps. If you can't remember what a set is, don't worry, it's pretty easy. Now, I really like these because basically we're building super fast, super efficient data structures essentially by cheating. It's fantastic. And then we'll top it off with graphs. Okay. Now, along the way for the class, right? So actually, let's just go ahead and text editor preferences. Yeah. Lots of colors. Yeah, I think upping this to 18 makes it stand out just that much better. Okay. So, along the way, we are going to learn about recursion. We're also going to learn about, in this chapter, we're going to learn about algorithmic efficiency, or algorithm efficiency. Yeah. Different ways of measuring how efficient your algorithm is. So algorithm efficiency, recursion. We're also going to learn about sorting. I think those are the big things that we really tackle. Don't think I'm really missing anything over here. Sorting is its own chapter. Recursion is its own chapter. Graphs are its chapter. Sets and maps are their own chapter. Trees are their own chapter. Stacks and queues together. We go over pretty much everything in this book. I'm going to try to tackle chapter 3 in this book, which is a thing that's in the newer edition. We are not going to tackle chapter 9. I'll mention that it exists, and I might, if I get ambitious, I might try to cram some of that material in here. But for the most part, these are it's a fairly short list, which segues, very nicely into our discussion about what I was just talking about, which is what is a list? So we define a list essentially as a collection of elements, each with a position or index. What does that mean? That means that it's a bunch of stuff. And more importantly, it's a bunch of stuff, and order matters for that stuff, right? Right, you have a first thing in the list, which is, in this case, lists, and then we have a last thing in this list, graphs, right? In this list over here. Then we have another list of topics over here. So we have two separate lists, right? And, in this case, we have, these subtopics. Ignore them for right now. That kind of breaks the metaphor. But the whole thing here is that basically item 1, we have lists. Item 2 is array list. Item 3 is linked list. Item 4 is stack. Item 5 is queues, right? These are items, and they're at a specific index, right? Although we're starting at 1, like we're in MATLAB or something like that. The point being is that a list is ordered, right? We have a first item, we have a last item in it, okay? And I can insert an item into the list. Let's go ahead and build a new list, something that you've probably built before. This is a shopping list, right? What are common things like that we get, right? So 2 common items I see on shopping lists for grocery: bread and milk, especially if there is a storm coming. For some reason, we always find the need to grab perishable items like bread, milk, and eggs in case there's a big storm coming, especially milk and eggs, especially if you lose power, those will hold up very well. So bread, milk, and eggs. Bread first, milk, eggs, some other items we might have, maybe some chicken that's also perishable. Let's go ahead and get like some apples as well, bananas, which my son is utterly bananas about. Let's go ahead and get some, peaches, because I happen to have gotten some today. Right, so this is like a shopping list, right? We have a first thing in the item, and the order may matter to me, like the order they appear may matter to me, well, but it's a shopping list, so not really. The first thing in my list is no more important than the last thing in my list. But there's an order, there's a top, there's a bottom, right? Now, order might matter to some people, or in some cases, like if I'm trying to make a list of alphabetical items, right? If I've got a list of everybody in the class, I like to make it alphabetical simply because it's easy to pass things back or keep track of who's who. Okay? So lists, we've kind of got that. They work exactly as you think they are. They're supposed to. One subtlety about lists, though, is that I can add items into the middle and I can remove items to the middle. I think it's actually a terrible idea to get some perishable items, so I can snip out these items, right? And apples is now the second thing in the list, right? So, and then I can put an item somewhere else, right? Butter, surprisingly not that perishable. Does a lot better, okay? Bread and butter. Actually, let's go with some, peanut butter, right? It can insert an item also at an arbitrary index in between two items, right? Okay. So that's what we've got going on there. So that's what a list is. So iterators, we're also going to learn about, especially, and I've got one implemented for you for your fourth assignment, so that you'll be working with an iterator. But those basically allow you to go through lists sequentially. So from the 0th item in the list, index 0, to the last item. So, so we've got this list superclass, or rather, of this. They're all so array list, vector, and linked list. We don't really go over vector. They're all subclasses of this master class abstract list, and they implement the list interface. Right? What the heck is an interface? Right? I'll get to that in just a second. But this, if you're keying onto this, this sounds a bit similar to an array, and it is very similar, right? Arrays are index data structures, and lists are index data structures, meaning they have indices, meaning things have an order, right? There's item at index 0 in an array, there's an item at index 0, and it goes all the way to index n-1. In a list, items will start at index 0, and they'll go all the way to index n-1, right? There's this inherent order. Now, this order may or may not matter, right? In our shopping list example, it doesn't matter that bread is the first thing in the list. It doesn't matter if it was the last thing in the list. It's all that matters is whether it's on the list or not. But with a list, there's a top of the list, and the bottom list. Maybe in this case, it represents what item I'm going to look for at the grocery store first. Okay? So that's what it means there's an index, meaning that I can ask for what's the third thing on the list, right? And that's apples. Right? So we simply can ask for an item, and we can go through and we can loop through it and go index 0, index 1, index 2, right? And get all those items. So the reason that list exists is because arrays, they're pretty awesome, but they're not awesome enough. Okay? The issue with an array is that you cannot increase or decrease its length, right? Big thing with arrays here. So here's a nice big classic put over here, right? I can make this this array over here. Int array. Let's call it R, because I like sounding like a pirate for saying R so much. New R. Sorry, int 100. So, now what am I going to do? So, I can just populate this, of course, with just data. So, for I is equal to 0, I is less than array.length, right? And I can just fill this up with just some garbage data. So, I'm going to give every value in the array every index in the array the value 100, because I can. Okay, but I cannot increase the size of this array. This array can only store 100 items, right? I can only store 100 hundreds, right? If I try to store an item at index 100, I'm going to get an error. If I try to store 101 hundreds, I get an error. get this runtime exception, this array out of bounds exception, which says there's I can't add this onto the array. Why do I get this error? Well, because an array is this contiguous chunk of memory, right? I tell Java over here, I need space for 100 integers. Okay? And Java goes, hey, no problem. You've got plenty of RAM, so here's a block of space just guaranteed for you that will work. It starts at this memory location, and it's 100 long, so implicitly it ends at this memory location. And that is reserved for you, and no other program is going to accidentally come in and mess with it. We've marked it that it's yours. And you're like, great. So, but say you need that extra space. Well, you've marked off this space. There was nothing stopping the computer or some other program from marking off this space over here, this space after the array, right? There's nothing stopping the computer from eating up this space. We can't expand over here. There's no guarantees that isn't taken. Right? So, can't really do that. You can't expand the size of the array. Okay? Other issues with the array is that if we want to insert an item into a specific position, sure, we can overwrite an item. But say you don't want to overwrite it. You want to, right, insert, say I've done all these things. I've added a bunch of numbers, and I want to insert an item, like in between certain indices. A better example would be over here, right? Say I wanted to insert an item like we inserted peanut butter in between bread and apples, right? In order to do that in an array, I have to move peaches over to a new spot, then I have to move bananas over to a new spot, then I have to move apples over to a new spot, basically, to make room, right? I have to sift everything over. And if I'm removing something, I have to do the same thing. I have to move everything back so I don't have a gap in my array. Alright, so I think this is a good length for this video because I'm going to start getting into what is a list interface. So we've talked about what is a list and how does that compare to an array. Last thing I want to mention though is that if you're coming from 1051, right, you may have noticed that you might be going, well, can't you use a .append method or something in Java? And the answer is no, because you can't do a .append method in Java because Python doesn't use arrays. It uses lists, the things we're talking about right now. So, so if you've been using Python, then great. You've been using these things basically the entire time. So next video, we're going to get into what is a list interface and what is an interface in general.